Hi there, I'm George Maestri. Today we're going to go over new character animation and rigging tools in Maya. Now this is for Maya 2020 and above. So let's start off with a little bit of an introduction. My name is George Maestri. I've worked in the animation business for quite a while. I've done just about every job there is. I currently teach at LinkedIn Learning. You may know it as lynda.com. And I've taught at a number of other institutions, and I've written a bunch of books. So let's go over the outline for this course. Now, Maya 2020 has introduced a number of new character tools, some of which will change the way that you rig characters. Probably the most important one is offset parent matrix. I'm going to spend a lot of time on that because you really need to get your brain around how that works. So we're going to go through offset parent matrix. Then after that, we're going to talk about some new pinning tools, proximity wrap, as well as some animation interface changes and cached playback. So let's get started with offset parent matrix. Now, offset parent matrix is probably the most important rigging feature of Maya 2020. It's probably one of the more important features ever to be added to Maya. Now, what does it do? Well, first off, it adds what's called a second transform node called an OPM, or offset parent matrix, to objects and nodes. It will simplify the way you rig. It will allow you to have fewer constraints, which will in turn free up the channel box. And most importantly, it's faster, so simpler and faster. And most importantly, it will change the way that you rig. So let's start off with a little bit of background. What is a matrix? Well, in Maya, a matrix is how Maya represents data internally. It can store standard attributes such as position, rotation, and scale, along with a lot of other stuff. So, for example, the attributes in the channel box or the attribute editor can be represented as matrices. So here we have some attributes for translation, rotate, and scale. And those can be translated into a matrix. Now, how this is done really isn't that important, but just know that this data is represented as a matrix. Now, if you want to transform an object in Maya, you will do it via matrix multiplication. So here we have an object that's at the origin, and let's say we move it to an arbitrary location in the scene. So how Maya does it is it takes the matrix representing that object's position, multiplies it by what's called a transform matrix, and then creates a new matrix which has the new data. Now, matrices are the foundation of all 3D operations. So everything from move, rotate, and scale, animation, deformations, and more. So everything is using matrices. So what is an offset parent matrix? Well, basically, it's just an additional matrix that can be used for 3D operations. It is applied before standard, position, rotation, and scale. And intellectually, you can think of it as just a second transform node that solves a lot of problems. Now, in Maya, we can translate objects using the manipulators. If I want to, I can just move that. The values will show up either in the channel box, and we can certainly type them here, or they show up in the attribute editor under the main node. So we have this transform attributes rollout, and that's basically the same values that you'd have in the channel box. Now, with Maya 2020 and above, we have another tab in the attribute editor, and that's called Transform Offset Parent Matrix. Now, this has two tabs underneath it. One is the matrix tab, and those are the raw values that Maya is using. But we also have a composition tab, and that's probably the more user-friendly interface. Now, this has translate, rotate, and scale, and we can just type in numbers into here. And what this does is it literally changes the world space of the object. So this happens before our transform attributes. So if I want to, I can move it up in Y, or I could rotate it in X, or really do whatever I want. Now, what this does is it actually changes the world space of the object. Now, why is this important? Well, let me show you an example here. So I'm going to undo my way out of this, and let's go ahead and turn on this layer here. Now, let's say we wanted to make the car go up the ramp. Now, your first instinct might be just to move the car into the ramp here and position it so that it's pretty much even with the ramp. But this introduces a problem. If you were to move the car up the ramp, what you're going to get is you're going to get a double translate. So you're going to get translate in X, Y, and Z, depending upon how you move this. So if I move this, you notice that Y and Z are both moving. And that's because its world space is not aligned with the ramp. And that's because it's literally moving up in Y while it translates in Z. Now, if we want to make our animation cleaner, we'd typically want to make the world space aligned with this ramp. Well, we can do that using an offset parent matrix. So if I hop over to the attribute editor, all I have to do is take these values and place them in the offset parent matrix. So my Y is at 2. So I'm going to go ahead and just type 2 into my offset parent matrix and 0 out my transform attributes. And so what that does is it literally just moves it. So I'm going to 0 out my Z translate and just replace that number in the offset parent matrix. And then do the same for rotation. I'm going to 0 out that 15-degree rotation and just put it in the offset parent matrix. Now what this has done is it's literally changed the world space of the object. So now if I look at it in the channel box, if I move it up in Y, that's all that matters. And the same along Z. So now all I have to do is animate along Z, and this basically corrects for that problem. Now this is very similar to what we used to do before with objects that had parenting to change that world space. So here I have another car, and typically if we look at that in the outliner, you'll see we have this NURB circle, and then the car is a child of that. So what you would want to do is basically just take that NURB circle, rotate it, and position it. And so by positioning this parent object, you basically can then move this object within that object space. And so this is a little bit more cumbersome in that it requires multiple objects and you have a hierarchy that you have to navigate. And this is why offset parent matrix can start to simplify your scenes. Now let's see how offset parent matrix can affect rigging. We're going to start with constraints. Now in rigging, we use constraints a lot, but constraints do have a lot of issues. There's lots of messy connections in the node editor. They can be slow because of those connections, and they also tie up the channel box so that you can't animate or move the objects outside of the constraint. Now, offset parent matrix can be used instead of constraints. It's probably going to become the new preferred method. There are fewer connections in the node editor. It's a lot faster, and it also frees up the channel box. So let's take a look at how this works. So here I have 2 characters and 2 surfboards. So we're going to set one up the old way using constraints and the new way using offset parent matrix. So let's take a look at how we normally would set this up using constraints. So I would say select the surfboard, position it, and then select the character, and then we can do a parent constraint, maintain offset. And once I do that, I can select that surfboard and the character moves with it. Now there's a problem because parent constraint does not also include scale. So I'm going to have to add a second constraint here for scale. Now once I have that, let's take a look at some issues that can crop up with this. The first is that if I look in the outliner, the actual character has these 2 additional nodes called constraints, and so those are additional objects in the scene. And if we go into the node editor and add those in, you'll see that we've got a lot of connections here. So we've got connections between the surfboard, the geometry, and all these constraints. And these are all things that Maya has to calculate. So this can get a little messy when you go into the node editor because you have all these connections. And Maya also has to calculate those connections. Now, another problem you have is that if I were to select this character, you'll see that all of these attributes are now taken up. The constraint is controlling the values of these. So if I were to, let's say, to reposition the character, so I can move him back on the surfboard, but as soon as I animate that surfboard, he's going to snap back because he's forced into that position. So the solution for that would be to add another object as an intermediary, which complicates the rig even more. Now we can do this a lot more simply with offset parent matrix. So now I'm going to take my character and select my surfboard. And let's go back into the node editor. Now I'm just going to go ahead and create a new tab here. And let's add in that character and the surfboard. So I'm going to work more with the main nodes rather than the shape nodes. So I'm going to move the shape nodes over to the side here. So what I want is I want the surfboard to drive his position. So we can do that very simply in the node editor using matrices. So my surfboard has a world matrix. That's where it is in the world. I can take that world matrix, plug it into his geometry matrix, and choose offset parent matrix. So what that does is it connects that character to the surfboard. Now you can see the character has jumped a little bit because what it's done is it's actually taken the exact values in the channel box for this and used it for the offset parent matrix. So if I go into the attribute editor, under his geometry tab, under the matrix, this value here will be the same as the channel box values of the surfboard. Now, the great thing about offset parent matrix is that I can move this character and reposition him. In fact, if I were to say zero him out in the channel box, he'll pretty much be on the surfboard. So now I can reposition my character if I want. I can move him back or forward because my channel box is open. And if we go into the node editor, you can see how simple this connection is. So this is the connection in the node editor for offset parent matrix, and this is the connection for constraints. So you can see how much simpler and more effective this is. And we get basically the same result. I can scale this. I can move it around. I can do whatever I want. So in this situation, the offset parent matrix is a lot better than the constraint. Now, offset parent matrix by itself is actually a little less flexible than constraints. So if I have this object here, if we go into, say, the outliner, and I go into my geometry, you'll see I have my constraints here, and I could actually delete that scale constraint and then just revert the actions of this so that when I scale the surfboard, the character doesn't scale. Now we can do that with offset parent matrix, but we do need to add in another node, and that's called a pick matrix. So if I go back into my node editor, you'll see that I have my two pieces of geometry connected here by the matrix to the offset parent matrix, and all I have to do is just hit tab and find the pick matrix. And we can use that to limit exactly what portions of the matrix are used. So I'm just going to delete this connection, plug the world matrix into the input of this. And the output of this goes back to the offset parent matrix of the object. So now I have this pick matrix, and if we go to the attribute editor, you can see it here. So if I were to, say, scale the surfboard right now, everything follows through. But if we go to that pick matrix node, we can basically just toggle off any of these that we want. So if I don't want to use scale, I can do that and I get pretty much the same results, and still I'm not blocking up the channel box, which is great. So if you want to isolate constraints, you can do that using a pick matrix with offset parent matrix. Now let's dive a little bit deeper into rigging and show you how offset parent matrix can help you set up control rigs for characters. So here I have some simple joint chains and controls. So if you're not familiar with rigging, typically how it works is you have this joint chain which deforms the mesh, and in turn that joint chain is actually controlled by these outside objects. Now normally they're curves, but you can use whatever objects you want. So the animator works with the curves, but the skeleton is basically hidden away from the animator. Now in the outliner, that basically looks like two separate hierarchies. So one for the joint chain, one for the controls. Now when you set up this control hierarchy, you want everything to be 0. So you have a default pose, and all you have to do is 0 it out to get back to that default pose. But we have a problem here, and that problem is that right now these objects actually have transformation values in them, and that's because they're in a hierarchy and that they're aligned to these joints. So I can't just 0 them out by going into something like modify freeze transformations, because watch what happens. If I select that object, notice how the axes of this object are pointing. If I do a freeze transformations, it resets it to world space. And yes, it zeroes it out, but now my controller is not aligned with my joint, and it's going to make animation really messy. So we need to find another way to do that. So the typical way, and the way that we've rigged pretty much forever, is to do something like this. So this particular joint chain actually has what are called offset nodes. So in this case, instead of having this object take up those values, so in this case, on the original, we had some values in translate X, Z, as well as rotate Y. So those values are actually placed into another node that actually takes those exact values and basically just offsets that joint by that amount. So now when I go to my control structure, I can 0 it out because that offset takes that value. And so now each one of these is at 0, but I also have this kind of invisible node sitting above it. So if you were to try to, say, pick walk through this, you're going to get extra nodes, and that can be problematic. So we can fix this by using offset parent matrix. So I'm going to turn these off, and I'm going to turn on another control structure here. And it's basically the same as the first one we have. So I've got these values here. And so what we can do is we can take these values, and instead of placing them into a separate node, we just place it into the offset parent matrix. So here I have the end of this chain. If we hop over to the attribute editor, go to that main node, you'll see that my translate value is 5 and change. So all I have to do is copy that value, place it into that translate node of the offset parent matrix. Now if I hit enter, notice how that jumps, but that's because we're getting a double transform. So I have that same value in the transform attributes as well as the offset parent matrix. But if I 0 it out in the transform attributes, I get 0 in the channel box, and my control is now at 0 without having to have that separate node. So we can do this again for this joint here. So if I go into my values here, this now has a translate and a rotate. Again, I can do that same operation, 0 out the translate, place it in the offset parent matrix, do the same with the rotate. Now this can get a little tedious, and so I have another method that I use to make it a little bit easier. So here we have this one, and this has actually 3 values. So instead of cutting and pasting 3 times, you can do a little bit of magic in the node editor. So I'm going to go into my node editor here, And here I have my control. And let's go ahead and just open that all the way up. So here on this control, if I click on this, you'll see I have offset parent matrix right here. And so what I want to do is actually connect the object's standard matrix to this offset parent matrix, and that will feed the values of the channel box into that offset parent matrix. So all I have to do is select matrix, plug it in here to offset parent matrix, and this jumps just like before, but if we go over to the attribute editor here, you'll see that all of these values are now fed into that offset parent matrix. So whatever you have in transform attributes, translate, rotate, scale, whatever, is going to show up here. So it's a fast way to move these in. But the thing is that this is a live connection. So if I move this in any way, it's going to go haywire. So what you want to do is just select that immediately, delete it, and then reselect your control object and just zero out your channel box. And so now I've got the same thing. I've got 0 in my channel box and my transform attributes as well, and also the values in my offset parent matrix. And so now I've got a control structure that's a lot simpler than I have with constraints. So if we go into our outliner, you can see that this has 6 objects in order to get this result, and this one here has only 3. And it's easier to walk through this. It's a much simpler setup. You have fewer connections too because you're not worrying so much about constraints. So hopefully you've got a basic understanding of offset parent matrix. Now this can be a very robust tool. I'm sure you're going to find a lot of uses for it, but let's just go ahead and sum up. First off, offset parent matrix changes the world space of objects without the need for additional nodes, and this will simplify your rigs. It can eliminate a lot of constraints and connections, but not all. You may still need constraints in some places. And again, it can streamline your rigs, make them faster, but most importantly, allows for many new ways to rig. So hopefully you can be creative with how you use this new tool. Now let's move on to some other new character tools. Let's take a look at the pinning tools in Maya 2020 and above. So pinning tools are basically just tools that attach objects or locators to deforming geometry. Now, there are 3 main tools that we want to take a look at. The first one is called Proximity Pin. It attaches to a surface by location or proximity. UV Pin, it attaches to a surface by UV coordinates. And Rivet, it basically just glues things to components. So these are all fairly straightforward, so let's take a look at them. So let's start off by doing proximity pin. Now this basically just pins stuff directly to geometry or the proximity of geometry. Now that proximity is determined by a locator. So what we want to do here is we want to take this character and we're going to attach this little object here and give him a soul patch and make him look a little bit more like a beatnik. So we can do that by basically pinning to the surface of the geometry. So we start off by basically just creating a locator. So I'm just going to go create locator. Now locators come in at the origin here. So I'm going to move that up and position it approximately where I want that soul patch to live. So once I do that, I need to select the geometry. So I'm going to go ahead and select this geometry, then select the locator, and then under the rigging menu constrain, we have proximity pin. Now if I look at the options for this, you'll see we have a number of them. One is input and output. Now input may be grayed out at the beginning. So it depends on what you select for output. So you may have to select this first. So I'm just going to do a new locator. So it's going to create a second locator here. And the input is going to be the existing transform. And then for mode, we have both edge and UV. So edge will constrain directly to geometry. UV will use the UV mapping on the character. And then just like with all constraints, we're going to have maintain offset. So it's going to create a new locator that maintains offset. We're going to go ahead and click add. And now we get a second locator. Now if we look at this in the outliner, you're going to see we have our original locator and our pin output, which is a second locator. Now the original locator is connected. So if I were to move this, that locator will move with it. I can also take that pin output locator and move it as well. Now this is pinned to my character. So if I were to move this, you can see that that pin output moves with the jaw. And again, that original can be used to kind of tweak things if you want. And now that we have this in place, we can just attach our goatee. Now we can do that in a couple of ways. We can use a constraint. I'm just going to get down and dirty and just parent it. So I'm going to go ahead and move that in, position it the way that I want. And now it is attached. So if I wanted to, I could move this however I want, and my soul patch moves along. So it's a very easy way to connect things to deforming geometry. The second tool we're going to cover is UV Pin. Now this is very similar to the way that Proximity Pin works, except it uses the UV coordinates of the object. Now in this case, I have this woman's head, and obviously she's UV mapped and ready to go. So you do need UV mapping for this to work. So we're going to basically just give her a stylish lip ring. And so I've already animated her just a little bit here so we can open her mouth. Now the nice thing about UV Pin is that it will work regardless of where the character is at. You don't need to have a default pose if the character is already deforming. You can use it wherever the character is. So I'm going to go ahead and select her geometry. And let's go into vertex mode. So we want to pin this to a specific vertex. And that vertex will be determined by the UV map. So in this case, I'm selecting this vertex. And what we want to do is go into Constrain UV Pin. And then take a look at these options here. So we want to pin to components. Okay, so vertex is a component. We want to output a new locator. If we want, we can have an existing object, but let's go ahead and create another locator. And then we can change our normal axes and so on. And I'm going to keep those at the default. So when we do this, what it does is it creates a locator, very similar to what we did with Proximity Pin. So if I go into the outliner, you'll see I have this pin output, and then I have my lip ring here. But that pin is already moving with the lip, so it's already there. So now all I have to do is attach this ring to that pin output. Now we can do this using a number of different methods. I could use a constraint, I could use an offset parent matrix, or I could just parent it. So let's just make this easy, and we'll just do some parenting. So now this is a child of that pin. And I am going to position this with her mouth open because it's much easier to see where it is. And let's go ahead and put that in and move it exactly where we want. So now we've got this object completely attached to the geometry and deforming with it. Now remember, UV Pin does need UV mapping, but most characters are already UV mapped, so it shouldn't be too much of an issue. And it's a great way to attach things to deforming geometry. Now let's take a look at the last tool, which is probably the easiest to use, and it's called Rivet. Now this will basically just stick something to the surface of an object. So here I have a character, and he's got some nice animation on him, but we went through revisions, and the director comes back and he says, you know what? We need to put the hat on the character. Well, how do we attach the hat? Well, we could use a proximity or a UV pin, but we can also use a rivet. So I'm going to scrub forward and take a look at this character here. So we're going to basically just take a look at this top of this character's head. And Rivet works basically with components. So it will attach to either a vertex, a face, or a UV. So we're going to do vertices here. So we need to just find a good place on his head to attach a hat. And that should be right around here somewhere. So I'm going to go into vertex mode and find the center of his head, and that should be a good place to do this. So now that I have this selected, we can use the Rivet command. So under Rigging, Constrain, you see we have Rivet. Now Rivet's really simple. It's one of the few tools that does not have options. So all we have to do is just go Rivet. And look what happens. We get a locator at the top of the head. Now if you notice, there's a theme here. All of these pinning tools create locators. So this one is very similar to what we have before. If we go in the outliner, we have pin output. Now I want to attach the hat to that pin. Now the easiest way to do that is to get the character into more of a neutral pose. Now I could drag this here, but the character's already animating and in a pose. So let's get him in a more neutral pose. And so if I go to my channel box under skin cluster, I'm just going to turn my envelope here to 0, and that zeroes him out. And then just take the hat, position it. Now again, I can position using any number of tools, everything from parenting to an offset parent matrix to a constraint, really whatever tool you want to use. And I'm just going to get this hat on his head reasonably close. And there we go, close enough. It's a little bit off this way. There we go. Okay, so that's pretty close. There we go, that's nice. Good enough. So now that I have this, I can basically, again, connect the hat using a variety of ways. And I'm just going to go really easy and just parent it. Let's select the character's geometry. Turn the skin cluster back on, and now the hat is attached. So very simple. And now he can go through the scene. You can take a look at this from the camera perspective. And there he goes. So Rivet is a very easy command to use. But you also have UV pin and proximity pin. So all of these work very similarly, but they allow you to connect objects very easily to deforming geometry. The next tool I want to cover is proximity wrap, and it's actually very simple. Basically, all it does is allows low-res geometry to deform high-res geometry. Now, this is great for animating a high-res character using a low-res proxy. Now, it's not pose dependent, so you can bind at any position the character is in. And it's also GPU accelerated, so it's reasonably fast. So now let's hop into Maya and take a look at proximity wrap. Now, we have two main objects here. I've got a low-res arm, and that arm is deforming. So it's already skinned and deforming. And then we have high-res geometry, which we will wrap to that low-res geometry. And you can see why proximity wrap is important, and that's because it's so much easier to skin and deform something like this than it would be like this. Can you imagine attaching every single one of those vertices to a skeleton? It would be a nightmare. Now, before we get started, I'm going to go ahead and select the arm and the bracelet, and we're going to just zero those out. And so now everything is coincident. Now, proximity wrap is found under the rigging menu, deform, and let's tear this off here. And it can be a little confusing here because we've got three proximity wraps here, here, and here. So under create, we have proximity wrap, and that just creates an empty proximity wrap that you can add the objects to later. So if I click on this, you can see I get this menu here. And that will create just an empty proximity wrap container that I can use. Now, under Edit Proximity Wrap, it brings up this menu here. Now, this is probably the menu you want to use the most because you can actually create a new proximity wrap here. And that's exactly the same as the previous menu, so you don't really need that menu. So I already have one here, and I'm just going to use that. And then finally, under Paint Weights Proximity Wrap, you have the ability to paint the weights of that proximity wrap and adjust it as you need. So let's go into Edit Proximity Wrap. And we've already created a proximity wrap container. And now all I have to do is add in the geometry. So that we have drivers and geometry. So drivers are the low-res cages that drive the high-res geometry. So if I select this high-res object here, I can add it to geometry. And you'll see it's right here. If I select my low-res shape, I can add it to the drivers. Now I'm actually going to scroll this forward before I do this. And one of the nice things about proximity wrap is that it will work even if the object is not in a default state. So if I add this selected, you can see how the high-res arm snaps to it. So you don't even have to be in a default pose to get this to work, which is kind of neat. Now once you have this, you can actually go through and edit that proximity wrap in the attribute editor. So if I go into my attribute editor, you should have a proximity wrap node, and then we have maximum number of drivers. That's how many vertices on the low-res cage are affecting the high-res cage. Fall off, again, how far from those vertices are we falling off. Smooth influences, we can dial that up or down if we want. It'll smooth out the deformation. And then smooth normals as well as soft normalization. So each one of these basically can make it work a little bit better if you want. Now, again, one of the nice things about proximity wrap is that you can use it on multiple objects. So if I go into this high-res object, go into that attribute editor, find my proximity wrap, I can edit that node and just select this bracelet and add it in as additional geometry. And so you can see that that basically adds in. It's not quite there yet, so we can basically just go back to that original proximity wrap and maybe dial up the influences and the fall off. There we go. The fall off is really what we needed. So again, just add a little bit more fall off, and now this works great. Now, one of the nice things about proximity wrap is that it is a lot faster. It allows you to deform meshes fairly quickly, and it's very easy to use. And finally, let's go over some interface tweaks with Maya 2020 and above. So we're going to take a look at timeline bookmarks, the graph editor, and cached playback. So let's go back into Maya, and we'll start off with timeline bookmarks. It's a great way to basically mark up your timeline so you know where everything is. It's a really handy feature. So here I have my character. He's walking through the scene. He jumps in. He looks up. He reacts. He antics, and he dashes off. Well, what we can do is we can actually bookmark that portion, those portions of the scene. And if I want to see the keys here, I can also turn on my controls layer, maybe select my hips. And to create a bookmark, all you have to do is just mark off a single key or multiple keys. So there is the hop for that character. And if I right click, you'll see we have a new menu here called Time Slider Bookmark. So all I have to do is create, give it a name. Well, that's the hop. Give it a color, and create. So now I have this bookmark that shows me that there's something important here. And if I want, I can right click under Time Slider Bookmarks and just frame that bookmark. And what it does is it expands the timeline, so all I have on my timeline is that exact bookmark. And I can get out of that by doing unframe. So let's go ahead and do another one. Let's do that reaction maybe. So again, I can create one. Let's give it a color. Call it React. And so now I have 2 bookmarks. And let's say we wanted one more for his antic. So from here to here. So now I've got a bunch of bookmarks. Now we can also go from bookmark to bookmark. So if I want to, I can frame the current bookmark. I can frame the previous bookmark, which is that reaction. And I can also unframe. Now if I want to, I can also delete them. And I also have the ability to edit my bookmarks. So if I'm on a specific bookmark, I can change the start and end time or the color or whatever. So it's really very straightforward. But as you can see, it's a very handy feature for animation, particularly when you've got a lot of keyframes. Now, some other improvements are to the graph editor. So if I go into Windows Graph Editor, you'll see that the interface is a little bit different. Now, one of the main improvements is that you don't have to use the Move tool anymore. So remember how you always had to select the Move tool to move keys? Well, now all you have to do is select them and they automatically move, and that is awesome. Now, by default, tangents are non-weighted. And you also have the ability to do interactive keyframes. So if I move my time slider here, I can right-click and just insert a key right here. I can also isolate curves. So if I have a curve selected, I can insert that key. I can isolate the curve. So if I've got a lot of keyframes in there, all I have to do is just a quick right click and a gesture, and now I can isolate curves and really focus in on them. Now we also have this nice scrubbable time marker. It's much easier to see and use. And also we can customize colors. So if you want, you don't have to stick with RGB. You can use whatever colors you want, and that's in the color editor. Now finally, Maya also has cached playback. Now this is a feature that you don't really see, but it's always working and it makes your scenes playback that much faster. So if you right click above the timeline, you will see cached playback, and you want to make sure that that's turned on. And then we can basically just see it by this blue line here. So anytime we change a scene, it recalculates the cache. So if I turn off my controls layer, you can see it can recalculate the cache. Turn on different layers, and again, every time that blue line refreshes, it refreshes the cache. Now, this scene isn't really that complex, so it refreshes pretty quickly, but it's always refreshing your cache. So if I were to say, take a keyframe here and maybe move them a little bit, you can see how this part of the timeline goes away and then it refreshes that cache. So again, this just adds to the speed of Maya and makes things go a lot faster. So that's about it. So thank you very much for attending this seminar. Now remember, I'm George Maestri, and I teach a lot of courses at LinkedIn Learning. So it's a great resource for anybody who wants to learn just about anything. Everything from character rigging to business to Photoshop. Really, we have a course for just about everything. And of course, thanks to Autodesk for helping make this happen. So I'll see you later.